To enable you understand the concepts, or rather how to conduct a cost benefit analysis, we are going to use this tool. It's a template that I've already prepared. You can download them from the description section. We are going to do an example of an inventory management, and we get to see how do we determine the return on investment, how do we determine the break-even point, how do we determine the net present value. So I'll populate it and I'll show you how it's going to look like when it's complete. And once completed, it's supposed to appear this way. Thank you. So walk with me. I'll take you through the steps as we populate it, as we do the particular calculations. So we are going to begin with the benefits. The benefits we anticipate from the inventory system. So one of it is going to be increased sales. In 2013, we expect it's going to be 500,000. In 2014, 530,000. In 2015, 561,800. And in 2016, 595, 508. The next is reduction in customer complaints. In 2013, that is 70,000. And for that, it's uniform, so we can autofill for the entire 4 years. Then reduction in inventory costs. So 68,000, which again is the same across the 4 years. After that, we now need to compute what are the total benefits. And to compute the total benefits, we just need to say sum, and then we drag that range and we press enter. It's going to give us that total, and then we can autofill for the rest of the columns. The same way, we can get the total at this particular point by saying equal sum, and then we select that particular range and you press enter. It's going to give us that value, and then we can autofill. Similarly, we can get the total here, which is sum, and you can drag that and we press enter, and it's going to give us the total benefits after the end of the 4 years, which is 2,739,308. The next thing we now need to populate is what we referred to as development costs. We have 2 servers, each is costing 125,000. So that gives us 250,000. There is also a printer that is needed, which is going to cost 100,000. There is also software license that is going to cost 34825. There is server software that is needed. Sorry for that. Then this is server software is 10,945. Then we have the development labor. So these are the salaries. So this is going to cost 1,236,525. Remember we said that development costs are one-off costs, and you can see they are taking place in 2012. That's when the inventory system is being built. And when the system is being built, we don't expect any benefits. That's why you can see that in 2012, we do not have any benefits. Benefits begin in the year of 2013 after the system has been built. So to compute, we sum that, and it's going to give us the total there. The rest of the years, of course, we are not going to have anything for that because the costs are only happening, the development costs are only happening in 2012. So the total here, I'll just put that. It's going to populate the same thing. The same case for this one, the same case for that one. You complete all of it so that you can have the totals. Let me borrow the template so that it appears more well organized. I think that's not right. Let me change it that way. Yes, it looks a bit better. After that, the next thing we now need to look at is what we referred to as operational costs. Remember we said that operational costs are the costs that are incurred when the system is in use. And one of it is in terms of the hardware. This could be maybe hardware maintenance, etc. It's going to be 50,000. And this is going to be the same for the 4 years. We are going to have software maintenance, that would be 20,000. Again, we also, it's going to be 20,000 across the 4 years. We are going to have operational labor. So these are the salaries for support staff who are going to be maintaining the system. So this is going to change. This is 115,000. The following year 119,600. The following year 124, 384, 129, 359. And those are the only operational costs we are going to have. Similarly, the same way we calculated the totals. So we are going to say sum. Then we compute that particular range. It's going to give us that particular total. We can populate it. Then we also compute the sum of the total so that we're able to know what's the total hardware costs, what's the total software costs, and I'm going to populate all that, and it's going to give me those particular figures. After that, the next thing that I now need to compute is what we referred to as the total costs. Remember, the total cost is supposed to be addition of both the development cost and operational cost. For the year 2012, the total development costs is that one, but the operational cost is 0. So the total costs is going to be equals that total plus the total here, which in this case it's a 0, and it's going to give us that particular figure. We can autofill. We can, so that we are able to determine that the total cost is an addition of total development costs and total operational costs. That's what gives us that value. And you can see it's addition of this cell H24, which is the total development costs, and cell H33, which is the total operational costs. After that, we need to determine what we refer to as the net benefit. Net benefit is a difference between the total benefits and the total costs. And how do we determine that? Is by clicking on the total benefits. In this case, we know that for year 2012, the total benefits is 0. So to determine that, we are going to say equals, and we click on the total benefits, and we subtract the total costs. And it's going to give us the net benefit into brackets, meaning that it's a negative. Then we can auto-populate that for the rest of the months, and we are going to get those particular values. You can see that only the first, the 2012, that's when we have a negative net benefit, but the subsequent years, the net benefit is positive. After that, we now need to compute what we refer to as cumulative net cash flow. This is a difference. When you're looking at cumulative cash flow for 2012, is going to be the same as this one, because that's the first outflow or the money out. The cumulative net cash flow for the second year, which is 2013, is gotten by taking the outflow for the previous year, then we add the inflow for that particular year, and it's going to give us that particular value. Similarly, for 2014, we are going to take the net cash flow for the previous year, we add the net benefit for that particular year, and it's going to give us that. To determine the net cumulative net cash flow, that is for 2015, we are going to pick the cumulative net cash flow for last year. We add the benefit we have collected for the year. You can see still we are operating on negative. Then lastly, for 2016, we are going to get the cumulative net cash flow for last year, and we add the benefit for this year, and it gives us that particular value. It gives us that particular value. Let's now determine the return on investment. And the formula for return on investment is the total benefits minus the total cost over the total cost. Or rather, we can say it's net benefit over the total cost, then we multiply by 100. So that means we are going to get the net benefit, we divide by the total costs, which is that one, and then we are going to represent this value as a percentage, and that is going to make our return on investment. Let's now look at the break-even point. The break-even point determines the period it takes for us to move from the negative to the positive, or rather, the period it takes for us to recoup our original investment. Remember, we invested 1,632,295. And you can see for 3 years, we are still operating in the negative side, and it's only in the middle of between the 3rd year and the 4th year, that's when we have shifted to the positive side. So whenever you are computing the break-even point, the first thing you need to check first of all is the number of years for which the cumulative net cash flow was negative. So that's the first thing. So the formula is the number of years that we are operating on the negative cash flow. So in this case, it's 1, 2, 3, which is 3. Then we add, and I'll put into brackets, the net benefit, and then we subtract the cumulative net cash flow for that particular year, and then we divide by the net benefit for that particular year. Because we want to determine between year 3 and year 4, when specifically did we move from negative to positive. And when we press enter, I need to change that to a number. So it's going to be 3.37 years. Return on investment and break-even point share one weakness in that they do not recognize the time value of money. In other words, the timing of the cash flow is ignored. And what we are all aware is that the value of money changes over time. Money loses value over time. The value of 100 Kenya shillings today might not be the same value 3 years or 4 years down the line. And therefore, we normally use a different technique, which in this case we refer to as the discounted cash flow, which is used to compare the present value of all the inflows and the outflows. In other words, what we are saying is that when you're talking of the benefits and the costs that we anticipate in some years to come, that might not give us the true reflection. And therefore, the best is to use the present value of those monetary terms in today's value, in the present age. And therefore, for our example, we are going to use a rate of return of 6%. So, to check for the first 2013, we are going to add a column here and we say PV of total benefits. And we are going to compute it as equals using this particular formula 1.06. Then we raise that because that is for year 1. And when we press enter, it's going to give us that particular value. We can reduce the number of decimal places. Similarly, for year 2, it's going to be that. Then we divide by 1.06. Then we raise it because that's for year 2. Similarly, we reduce we go to year 3, which again is that, divide by 1.06, that is 3. We similarly do the same thing, and then lastly 1.06. This is year 4. And we also do the same. We can borrow these formulas. Sorry. We need to remove that. Then we can get similarly the totals for the present value. And we're going to drag that, and it gives us that particular value. In other words, what we are saying is that the present value of the total benefit in 2016, which is 733, in today's dollar terms, it's 581,007. When using present value, it's more accurate in determining whether it's worth to invest in a particular project. We do the same for the total costs. So I'm going to add a column here, and I'm going to say PV of total costs. And in the same manner, we are going to begin with this one, then over 1.06. So this is year 0 because that's when the project is being undertaken. I can autofill, but I keep changing this one so that this is year 1. And I make sure to remove the decimal places. This is year 2. And I make sure to remove the decimal places. Then this is year 3. I make sure to remove the decimal places. And that is year 4. And I make sure to remove the decimal places. And of course, I also get the summation of that particular range, and it gives me 2,296,686. I also remove. When you're determining the net present value, you normally take the PV of the total benefit, then you subtract PV of total costs. And to determine that, we just need to go and look for the PV for the total benefit, which is this one, and we subtract the PV of the total costs, which is that one, and we press enter. And we can borrow that formatting and we attach it at that given point, and we can remove the decimal places. Sorry, I don't know how the return on investment changed itself. Let's just calculate it. It's supposed to be net benefit, which in this case it's this one. Then you divide by the total costs, which is that one, and it's going to give us 14%. So what do these metrics mean? Any return on investment that is positive or that is greater than 0, it means that that project is worth to be invested. If the return on investment was a negative one, then it's recommended not to proceed with that particular project further. The next one is the break-even point. It means that this project will break even in the 3.37 years. So the shorter the period, the more favorable a project should be allowed, because it means that it's going to break even within a shorter period of time, and the organization will have then the net present value. If the net present value is a positive number, like in our case is 68,291, then it means that the project is worth to be invested. However, if the net present value is negative, it means that the project is not worthy to be implemented. I would wish to thank you for listening. Bye-bye.